So today's talk, as it says, is a whistle-stop tour of streaming with Delta sharing. And hopefully, if we have time, we're going to include a live demo at the end. After Casey's performance this morning, which got the crowd going with the live demo, spectacular fail and recovery, I thought about introducing a few bugs, but a bit too risky. So we'll see how it goes. Hopefully the live demo will work. So just to introduce myself, I'm Matt Slack. I'm a SSA, so I'm basically a technical specialist in data engineering. I've got a background in streaming, so typically like things like Kafka, Kinesis, event hubs, etc. So let's make a start. So where did this use case come from? So end of last year, we started working with a customer. Customer is a data provider for finance data, one of the biggest in the world. And they want to, well, they're already selling loads of data products with different mechanisms, like file transfer, fairly traditional things. But they obviously had a bunch of customers who were already using Databricks, and they wanted to explore Delta sharing. So they'd already started using Delta sharing in kind of batch mode, making these tables available. These are some of the kinds of data they're selling on the screen there. So they're already making these products available in batch. But of course, being financial information, market information, obviously latency is important. So they wanted to provide a way to their customers to get this data more frequently, be able to detect updates, detect changes. But the key thing was they didn't want to add in a load more infrastructure overhead on the customer. So yeah, of course, like, if you're doing things like real-time trading, you're going to be looking at like pure streaming stacks, Kafka, etc., low latency. So this wasn't really going after that use case. It was more going after customers who maybe didn't have the capacity or the engineering teams to spin up, big infrastructure estates. Customers who were maybe already using Databricks, already consuming tabular data, but they wanted to provide a mechanism of updating that data more frequently. And they were aiming for about sub 10 seconds. And the key thing was kind of keep it simple, allow the customer to get this data without making huge changes to their existing technology stack. So that's where this grew out of. And this is where we started to explore with them streaming for Delta sharing. So why was this a good fit for this use case? Well, okay, it's not going to replace Kafka, not yet anyway. But the latency you can achieve, as I'll go on to show later on, hopefully in the demo, fingers crossed, is around 10 seconds. Obviously, there's a lot of dependencies. If it's cross-cloud, it's a bit slower. If it's cross-region, it's slower. But if you're in the same region, you can get reasonably good latency. So for some of those data products you saw on the previous page, that was fine. And it supports high volumes of data because under the hood, Delta sharing is still pushing around Parquet files. Obviously, Parquet typically has great compression. So you can push through fairly high volumes of data, 100K per batch, million records per batch, because it's really under the hood, it's just pushing those files around. So actually you still get great compression. You're going to get as good compression as typically you'd get on something like Kafka. And it unlocks many of the use cases. So some of the use cases they wanted to do were things like enabling their customers to do anomaly detection or do some like near-ish real-time dashboarding off the back of this data. So because only the changes are getting pushed to the customer, rather than the customer querying the table, the customer can see what's changed and then they can run a model or something like that. So, and we'll see in this demo, hopefully if it works, we have a real-time Power BI dashboard. So we'll try and see that working as well. And then, of course, the other benefit is it's super simple. The whole Delta sharing architecture is really simple. It's a simple approach. It doesn't require too much infrastructure. Obviously, there's the open source option. There's the open source server as well. So it's quite simple. You don't need to be spinning up extra infrastructure. It requires management. And a really big win here for me, obviously, as someone who's come from like a streaming background with things like Kafka, is always with Kafka and those kind of architectures is you have to think about serialization. And sometimes it's a right pain in the neck, because data types don't match, you have conflicts between Avro, protobuf, you have to have a schema registry, you're taking data from source and then you're putting it to a table and you find, you then got to have schema management, schema evolution, all these kind of things add overhead and complexity and time in terms of building, cost in terms of building to support these kind of things. So with delta sharing, because it's still just a delta table, the schema can evolve. That's all fine. The end user can even detect that the schema's involved if they want to. They can detect those events. So a lot of that headache of type mismatches and all that kind of thing goes away. And then one thing that was big for this customer was having the same semantics for batch and stream. So customers were already querying tables. They knew the table columns. They knew what the tables looked like, the data in them. So of course, the semantics were exactly the same with streaming. All the columns were exactly the same. They could work with the data in the same way. So let's just have a recap of the delta sharing architecture. So this is, if we take streaming out of the question, this is a quick overview of the delta sharing architecture. So essentially, what happens when a client makes a request? So let's roll back a step. Obviously, you've got to set up the recipient and the share in Unity catalog. And then you pass the URL to get the credential to the client. And then the client downloads the credential, and then they can start accessing the data. So the first thing that's going to happen when a client requests a table is they're going to connect to the sharing server, request the table. That could have partition filters on it because you can have customized permissions according to what partitions people have requested. So that's all get passed to the server, and the server checks against Unity catalog to say, does this person have permissions to this data? If they do, then it gives them back a list of URLs secured with either cloud tokens or pre-signed URLs to the actual data in blob storage so they can go and get it. So on the client side, it uses those URLs to download the data from the blob where that data was stored. So that's the standard delta sharing architecture. Pretty similar with open source and Databricks to Databricks. It's all fairly similar. So what's the difference when we switch to the streaming mode? Okay, so the main change is the authentication is exactly the same. You still use a credential file. But in this mode, when you start the streaming pipeline running on the client, it's going to start polling for new table versions. So it's going to, every so often, based on your trigger interval on your structured streaming pipeline, it's going to poll the delta sharing server and say, are there any new versions appearing in the delta log for this table that I'm sharing? So it will say something like, my current version is like 1706. And then if there's no new data, it will just poll every so often. And then if some more data is written to that file, the version will obviously go to 1707. And then when it makes a request, okay, there's some new data, right, let's get it. So assuming it's got the access permissions, it then passes just the URLs of the files which are in that version. So it's going to be quite small list. So if when you wrote to that delta table, you wrote 5 new files, the pre-signed short-lived URLs will be generated for those 5 files, and that will be passed to the client. So it's just downloading the data for that delta table version as it's changed. What's important to mention, and worth bearing in mind if you start to set up this type of architecture, is that the client's maintaining the table version in the structured streaming checkpoint. And why that's important is because if you start vacuuming the table that you're consuming from in Delta, you might just have a monthly or weekly vacuum process. If you've got clients who haven't connected for a few weeks and they suddenly start connecting, it's going to complain. It's going to say that version doesn't exist anymore. So you have to be careful, and I'll show you at the end if we have time, how to keep track of where clients are up to in terms of consuming Delta table versions. Okay, so what sort of things can we do based on that architecture to improve latency? Well, the first thing to say is that by default, Databricks deliberately makes the client throttle. And that's because essentially we don't, unless someone really needs a lowish, like a low latency data stream, let's start off with just adding some throttling just so the client can stream the data, but there's some built-in throttling there. And you can see the effect that has on the graph at the top is actually the throttling means that every other request is throttled. And so you can see the spikes in the in the batch duration while it's throttling, waiting for data. By default, that setting you can see on the screen is set to 30 seconds. So what it'll do is every so often it will throttle for 30 seconds, making sure the server's not being overloaded. And when it's done the throttle, then it'll start again, consuming the versions. Now, when we first brought out Delta sharing streaming, that was set to 30 seconds, and you couldn't change it. You couldn't bring it down below 30 seconds. We've now enabled it down to 10 seconds, and we're doing work in terms of the architecture, splitting out Delta sharing server from Unity catalog, so they're a bit more, independent. So actually, we can bring that down lower to potentially like closer to 0 seconds. So another thing that can delay, and this when you see when we actually start running it, is that all of this is limited by how fast the data can be queried from blob storage, because there's no Kafka, and typically for every new version you read from the Delta table, there's like 3, 4, or 5 different API round trips to blob storage, which all take time. So typically, you're always going to be delayed a little bit by blob storage. So if you're in Azure, you might want to consider using something like premium blob storage to bring that down. And I think Delta sharing streaming is always going to be limited under the hood by the underlying blob performance. Another gotcha that's good to remember is because Delta sharing is effectively creating these pre-signed URLs or cloud tokens which access underlying files, is that if you have a partition table, you're going to potentially have a lot more URLs and files being passed around. So that can slow things down as well. So for example, if you're writing to a Delta table and it's partitioned by business unit, and you've got 20 business units, then potentially every Delta table version may write a new file into that business unit's partition. So when the streaming jobs come along and consume from that, instead of consuming just one file, they're going to have to consume 20 files. And so that puts an overhead on the Delta sharing server, which has to generate those URLs. So worth bearing that in mind as well. So what latency is actually achievable? Okay, so this is kind of typically where I could get to in testing. Now, it's interesting, I was running this now, obviously, when I first did this, set up this demo. In fact, when I generated the graph, I was running this in the UK. I think because of the time difference, the US, it was running in US Azure, was a bit quieter, and so things are faster. So you will see actually this latency changes over the day as blob storage gets, it's being more used, and the Azure services generally, there'll be some kind of peaks and troughs throughout the day, but this is typically the performance you can get. So without switching off the back off, with the default back off of 30 seconds, you can average about 15 seconds. If you bring the back off down, the fastest you can get it with no back off is average about 3 or 4 seconds. So that's pretty good for a lot of use cases. Obviously, this was in the same region, so this was 2 different Databricks workspaces, independent workspaces, but in the same region. Cross region is the yellow line, so that was Azure east to west. You're adding on about 3 or 4 seconds of latency, and then green was Azure to AWS. So still, it's covering a lot of use cases. Okay, I will come back to that one. Okay, let's dive into the demo. We're already 40 minutes in. Okay, so this is the rough demo architecture. So typically it would be polling from like a WebSocket or an API, but in this case we've just got Python generating synthetic data based on the kind of news story. It was news data, financial news data, so it's JSON payload, generating synthetic data. It's consuming from a queue, and then we build a pandas data frame, and then we write that down to a Delta table with Spark. So the Delta table is shared through the sharing server, and then the other end of that, we've got a client. I've already set up the credentials, so the client's already consuming from that. And we're using this format, structured streaming pipeline, spark.readstream.format Delta sharing. And that tells us that we're consuming a Delta sharing stream. And off the back of that, I've got a Power BI dashboard using an API. So let's see if we can jump into the demo. Okay, so this is the kind of example data. It's just like news stories relating to the stock market. So I have a Python script. I'll skip straight down to here. And the Python script is just doing a simple write to a delta table. Every so often we do an optimize, and that's because we want to keep the delta log quite compact, because the delta sharing server is reading the delta log, so we're optimizing much more often than we would on a normal delta table. We're optimizing, I think, once every 100 batches. And then I've had this one running. I hope it's still running, and it is. So this is running, writing to a delta table about once every second. And it's a medium amount of data. You can increase the number of data because it's still just writing a few files every time. Actually, you can increase the data quite substantially, and the latency still quite good for writing to delta tables. Right, so let's switch to the client, which is obviously where it's more interesting for this. So you can see I've set this to 0 seconds. At the moment, you can only set it to 10 seconds. That's the minimum you can go to, but I'm setting it to 0 seconds to kind of show you the art of the possible of where we're trying to get to with it. Using the syntax I described before, format delta sharing, and then we pass in the credential file, or the reference to the credential file, and the table we want to assume from. And this is in premium storage, which gives us a little bit more performance, not much. So, I'm then doing some simple windowing by every minute just to calculate the latency like for every minute. So if we scroll down to the bottom, so this is the most recent batch, was about 7 seconds average for 360,000 rows. So it's okay. Would support quite a lot of use cases. At quieter times of the day, you can actually get it down to like 4 or 5 seconds, as I showed on the graph. And then let's just jump into pushing this to the dashboard. I've got a simple API call to the Power BI API, which does the real time. I say real time, it doesn't update that quickly, to be honest, but it does push the data to the streaming data set in Power BI, which you can then have a visualization. And then this is running as well off the same stream. So you can see here that's processing. If I switch to the dashboard here, it will update, I think. Obviously, we would use Lakeview, but at the moment you can't kind of do a push API with Lakeview. I'm sure it's coming. But so this is just showing the volume of records by minute, I think. Very simple UI. It's quite primitive, the Power BI real-time API dashboard. So that's the demo. It seems to work. So one thing I did touch on, which we'll jump back into, is how do you keep track of where consumers are up to? Because obviously, if this is, you probably would quite like to do your delta share to multiple customers, and they might all be at different places. You don't want to have a different share per customer, so they might all be at different versions. So how can you find out where they all are? So of course that's stored in the checkpoint file in structured streaming. So the latest version consumed from the table is stored in the checkpoint file. But fortunately, in the audit logs, so this is the system access audit table here, you can see the audit logs. And in here, we can see what version it's up to. So you can see this is the table we've just consumed, and this is the table version it's up to. So you could keep track of where consumers are up to. You could get a consumer on the phone. So you haven't connected for 2 weeks. Your version's out of date. You're going to risk losing data. So what's going on? Or you could even use this to do some kind of primitive latency calculations. How fast are people consuming the data? How much data are they consuming? That kind of thing. You could even use it to do billing. So you could say, well, you've connected to pull down this much data from your stream. Okay, we're going to bill you this much. So you could drive billing off this data set as well. Okay, so I'm about time up. I hope that was really useful.